Hey everyone, so welcome back to my channel, and today I'm excited to show you how I managed to implement a Quadtree into my 2D shooter game, making it way faster than using regular collision detection. I have even prepared a small demo you can see in the background to just show you how powerful this technique can be. So as you can see in the background, I have around 300 circles, which basically when they collide, we change the fill color to green. And you can see it's on stable 40 to 45 FPS. That is using the Quadtree. Now if I just switch Quadtree off, if we do a normal collision detection, and if it can load, you can see that it's on 15-ish FPS. So you can see just how fast and optimized Quadtrees can make your game. Now before we get into the code, I would like to just spend a little bit time talking about what a Quadtree actually is. So a Quadtree is a tree data structure used to efficiently represent a 2D space. Each node in the tree represents a square region, and it's divided into 4 equal-sized quadrants. So Quadtrees are great for tasks like, for example, collision detection, which I will use for my game, and also rendering optimizations. I definitely encourage you to check out the Wikipedia page on Quadtrees. It's really good. So I will leave it down in the description below. In this Wikipedia page, actually, there is even a pseudocode which you can use. I have used this pseudocode to implement it in C++ and SFML without any issues. I started with creating the actual Quadtree class, obviously. So this has some following attributes, for example the boundary. It also has a capacity, so that's the maximum number of points before the tree should subdivide. We also have a list of points. Now this is a custom class which I will show you a bit later on. It's not important as of now. And then obviously the 4 pointers to our child node. Then for my CVP file we have some essential methods like insert, subdivide, and query range. So the insert method is used to add a point to the Quadtree. So if the current node has reached its capacity, we subdivide it into 4 child nodes using the subdivide method. The query range, which is right here, is used for finding all of the points within a specific range, which we give it as a parameter. And this function we will use later for collision detection. Now, to make the Quadtree work with my game itself, I had to create a point class, which is super helpful since Quadtrees are very generic. The point class has the following attributes: the tag, which is it's a string to identify the type of the object. For example, is it a bullet, is it an enemy, and so on. The boundary is obviously a float rect representing the object's boundary. Next, the index is the index of the object in its respective vector, because if I go to my game manager, you can see that my bullets and my enemies are split into 2 different vectors. That's why I had to add this index to see which the index of the object in its respective vector. Alright, now let's talk about the actual collision detection using our Quadtrees. So first we have to clear the Quadtree every frame, since the position of the bullets and enemies and all of the different entities change. Then we can insert the updated points for each object into the Quadtree. You can see that in my fixed update, once the bullets have updated their position and so on, then I go ahead and insert the point using the global bounds and so on. Same with our enemy. And then finally we loop through the bullets. I query all of the points which are inside of this bullet, and then I added this little check because we don't want collision detection with bullets and itself, right? I don't want, if a bullet hits another bullet, I don't want anything to happen. For your game it might be different, but for my own game this is what works. And then is it an enemy? Okay, and did the player shoot this current bullet, and does it now collide? If all of those are true, well then enemy took damage. And then this is what I needed for the index, right? I added this, so the enemies with its respective index, I take damage and then the damage amount. And then I also added this to remove, which after this all have finished, I simply loop through all of the bullets and then I erase if there are two removed. Same with the player. Like, okay, is the point a player? If the player didn't shoot it and the player intersects that bullet, well then the player took that. So here's a bit of a summary of this code. I know it seems like a lot, but it's really not. So first we start by clearing the quadtree, then we update bullets and enemies, and then we insert their points onto the quadtree. Then we loop through all of the bullets, query the quadtree for nearby objects, check for collision between bullets and enemies or the player, and then remove bullets that need to be removed. Alright, so I think that lastly I can actually show you the quadtree in practice and show you how it looks on the game so far. So if I just start, and yeah, you can see the quadtree gets subdivided correctly and so on, and you can see that the bullets collide correctly with the enemy, same with the player. And you can see that, yeah, I mean the enemy is dead as hell and shit, so is the player now. I haven't implemented the actual enemy dying and player as well, so that's why I just print it out. But yeah, you can see that everything works as it should, and you can see, I mean, it's unstable at more than 1500 FPS. It will be even more, because right now when I'm shooting and it shoots off into space, you know, basically outside of the window view, I don't delete the bullets, so you know, this will be even further optimized. And that's it. So with the quadtree implemented in my 2D shooter game, I have significantly improved the collision detection performance. So, but please keep in mind that the quadtree can be optimized even further, but for my purposes it works great as is. So thank you so much for watching. If you found this video helpful, be sure to hit that like button and share it with your fellow game developers. Don't forget to subscribe to my channel for more tutorials and tips. If you have any questions or suggestions for future videos, drop a comment down below. I would also like to mention that I'm streaming every Tuesday and Friday, 5 p.m. CEST, I think it's called. But today I'm actually planning on streaming a bit earlier because I don't really have anything to do. But yeah, I mean, if you're watching this video, there might be a chance that I'm streaming, so you're always welcome to, you know, drop in and say hi. So yeah, thank you so much for watching and see you around.